This video shows the power supply structure of the NE40E-X8A and NE40E-X16A, and how to connect power cables. This video covers 4 aspects: power system structure, device power consumption calculation, PM configuration, and power cable connection. The power systems of the NE40E-X8A and NE40E-X16A are located at the bottom and top of the chassis, respectively. A power system mainly consists of the PMs, PMUs, and switch at the front of the chassis and the PEMs at the rear of the chassis. External power sources provide power input for PEMs, and PMs convert the input to power the entire device. The NE40E-X8A and NE40E-X16A support flexible power supply. The number of PMs can be configured based on the overall power consumption of the device. The total power consumption of a device is the sum of the maximum rated power consumption of all working modules configured on the device. To calculate a device's total power consumption, you can use the hardware configuration tool provided by Huawei Info Finder. Log into the Info Finder website, click Hardware Configuration and Filter, and select the corresponding chassis by product. After configuring boards, PMs, and fans according to your scenario, click Calculate to obtain the device power consumption, recommended number of PMs at power backup mode, and other information. To calculate the minimum number of PMs required for the device, divide the total power consumption of your device by the maximum power that 1 PM can provide. If the result is not an integer, round up it to the nearest integer and add 1. PMs can work in either N+1 or N+N backup mode, depending on the PM type. In the case of -48-volt DC power supply or dual input AC and HVDC power supply, PMs support N+1 backup. *1 represents the number of backup PMs. For example, if the previous calculation determines that the device requires 3 PMs, then 4 PMs need to be configured. If one working PM fails, the backup PM provides power supply to ensure the normal operation of the device. In the case of single-input AC power supply or single-input AC and HVDC power supply, PMs support N+N backup. N represents both a number of working PMs and the number of backup PMs. For example, if the previous calculation determines that the device requires 3 PMs, then 6 PMs need to be configured. When all the N working PMs are faulty, the device can still work properly. After installing PMs, ensure correct mapping between PUMs and PMs when connecting power cables. The NE40E-X8A has 2 PMs and can be configured with up to 8 PMs. In the case of -48-volt DC or dual input AC and HVDC power supply, each PM has 8 inputs, totaling 16 inputs. Each PM has 2 inputs, which are from power sources A and B, respectively. In the case of single-input AC or HVDC power supply, each PM has 4 inputs, totaling 8 inputs, with each input corresponding to 1 PM. Take the DC power supply as an example. For the PM installed in slot 1, its power should be sourced from ports A1 and B1 on PEMs. The NE40E-X16A has 4 PEMs and can be configured with up to 16 PMs. In the case of -48-volt DC or dual input AC and HVDC power supply, each PM has 8 inputs, totaling 32 inputs. Each PM has 2 inputs, which are from power sources A and B, respectively. In the case of single-input AC or HVDC power supply, each PM has 4 inputs, totaling 16 inputs, with each input corresponding to 1 PM. For example, in the DC power supply scenario, the PM installed in slot 1 sources its power from ports A1 and B1 on PEMs. When the device uses different power supply methods, the corresponding method for connecting power cables varies. In the -48-volt DC power supply scenario, the power cables connect to the device through OT terminals with power sources A and B for the equipment room connected to PEMs Type A ports and Type B ports, respectively. In an AC or HVDC power supply scenario, power cables connect to the device through mains plugs, with power sources A and B for the equipment room connected to PEMs Type A ports and Type B ports, respectively. In the dual input AC and HVDC power supply scenario, Power cables connect to the device through power plugs in either of the following ways. Method 1. One power source connects to all Type A ports on PEMs, and the other power source connects to all Type B ports on PEMs. Method 2. Each power source connects to half of the Type A ports and half of the Type B ports on PEMs. When connecting the device to power sources, add protective components and ensure that the input meets requirements. When the device uses DC power supply, the input current is no less than 63 amps per channel. When the device uses AC power supply, the rated input voltage is 200 volts to 240 volts single phase, and the current is no less than 16 amps per channel. If the device uses HVDC power supply, the protective components must pass the HVDC certification, and the input current must be no less than 14 amps DC per channel. That's all for this video. Thank you for watching.